Hello, it's Mrs. Scarpel, and we are going to look at our third method for solving systems of equations. So far we have looked at solving systems by graphing, so we would get our equations in slope-intercept form, y equals mx plus b form, and graph each line, or use x and y intercepts to graph each line. Or we would solve an equation for a variable. We would get x equals or y equals, and then substitute into the second equation to solve for a variable. But now we're going to use what we call the elimination method. Think about what it means to eliminate. Eliminate means to get rid of something. So we want to eliminate one of the variables in our system in order to solve for a variable. So think about how you first learned to add when you were first learning to add in elementary school. You probably lined things up with a bar underneath, and that's exactly what we're going to do here. Now if I look at this system, we have negative 2x plus 3y equals 4, and we have positive 2x minus y equals 8. So if I add, notice my x's are lined up vertically, my y's are lined up vertically, my equal signs are lined up, as are my constants. So that is one of the requirements. Everything needs to be lined up accordingly. And then when I look at this, I need to have something that is opposite. So I have negative 2x and I have positive 2x. Negative 2x is the opposite of positive 2x. So that becomes 0x. But we all know that if we have 0x, that's essentially saying that the x terms are going to cancel out. So now I can combine 3y with a negative y. And again, that's a negative 1y. So 3y minus 1y is 2y equals 4 plus negative 8 is negative 4. So now we have the equation 2y equals negative 4. We can solve for y by dividing both sides by 2, and y equals negative 2. But just because we have y, we should know that we haven't solved our problem, because remember, a solution to a system of equations is a point. So we still need to solve for x. And we can choose either equation to solve for x. I am going to go ahead and use the second equation, the 2x minus y equals negative 8. So 2x minus negative 2 equals negative 8. And a subtract negative is actually 2x plus 2 equals negative 8. Subtract 2 from each side, and we have 2x equals negative 10. Divide both sides by 2, and we have x equals negative 5. So what we're saying is the solution should be, remember our solution is an ordered pair. Ordered pair has x first, negative 5, comma, negative 2, and ordered pairs are always in parentheses. So let's check. Did we do this correctly? Remember to check, you substitute the point into each equation. Does negative 2 times negative 5 plus 3 times negative 2 equal 4? That's the question. Will that equal 4? So negative 2 times negative 5 is 10. 3 times negative 2 is a minus 6. 10 minus 6 does equal 4. That's true. So far, so good. Let's check it with the second equation. 2 times negative 5 minus a negative 2. Will that equal negative 8. 2 times negative 5 is negative 10. Subtract a negative 2 becomes plus 2. Negative 10 plus 2 does equal negative 8. That is true. So we have found our solution successfully. Is it still possible to use the elimination method if in the process of lining things together there are no obvious opposites? So I have a positive 3x and a negative 6x. My x terms are lined up, but they're not opposites. I have opposite signs, but not opposite values. I have 2y and a minus 5y. Y's are lined up. I have opposite signs again, but not opposite values. Equals negative 2 over a positive 2. Now these are opposites, but it wouldn't eliminate one of my variables. So we need to think about, is there something I can do to one of my equations to help me create opposites? Keep in mind that if you do multiply an equation, as long as you multiply everything in the equation by the value, you can create an equivalent equation. So when I was looking at this 3x and this minus 6x, it did occur to me that if I take 3 times 2, that would become a 6x, and 6x is the opposite of negative 6x. So if I take everything in this first equation times 2, my new system will be 6x plus 4y equals negative 4, because I have to take everything in that first equation times 2, everything, not just the left side, and I can keep the second equation the way it was. I don't need to change that, and I don't want to change that, because I do need to have opposite values for one of my variables. And by multiplying the first equation by 2, I now have opposite x values. So now I can combine, I can add the two equations together, and those x values will eliminate, they will cancel each other. So now I have 4y, subtract 5y is negative 1y, equals negative 4 plus 2 is negative 2. Divide both sides by negative 1, and we have y equals 2. Now we still need to solve for x. So to solve for x, I am going to go ahead and use the equation that had x and y, those terms were positive. So I'm going to go ahead and use the first term to solve for x. So 3x plus 2 times 2 equals negative 2. 3x plus 4 equals negative 2. Subtract 4 from each side. 3x equals negative 6. Divide both sides by 3, and we have x equals negative 2. So our solution is negative 2, 2, x followed by y. Let's check. Three times negative 2 plus 2 times 2, does that equal negative 2? So that would be negative 6 plus 4, and negative 6 plus 4 does equal negative 2, so that's true. Let's check the second equation. Negative 6 times negative 2 minus 5 times 2, does that equal positive 2? So negative 6 times negative 2 is positive 12. Negative 5 times 2 is minus 10. 12 minus 10 does equal 2. That is true, so we have solved it correctly. So when you're solving using the elimination method, you are looking to make either your x terms or your y terms opposites, and you may need to multiply one of your equations to make opposites happen.